So taking a look at the next page, we're still going to continue with these trig limits by trying substitution first. And notice how at first glance these next three might be a little cumbersome because we have multiple trig functions to evaluate in each of them. And I don't know about you, but trying to evaluate more than one trig function could be time consuming depending on your knowledge of the unit circle. So what's nice about trig functions is that maybe we can use some of their properties or ways that we can rewrite them to our advantage. So for instance, if you take a look at the first one, I really don't feel like plugging in 3 pi over 2 into both of those trig functions just to see if we get a number out, or perhaps 0 over 0. So before I try substitution, I'm going to try to rewrite the way the function looks. And we can do that by utilizing some ways that we can rewrite tangent or secant or some other trig values. So instead of tangent, we'll go ahead and write sine over cosine. And by doing that, notice how the cosines would conveniently cancel each other out. So we're just left with 3 sine. So instead of plugging in 3 pi over 2 into the original function, we could essentially plug it in here and we would get the correct limit value. So 3 sine of 3 pi over 2. 3 pi over 2 is a location on the unit circle that we have to know. That's the very bottom point, and the sine value at that spot is -1, so our limit value would be -3. Very similarly for number 2, I really don't feel like plugging in pi over 2 into those trig functions, so before I do that, I'm going to try to simplify it so it's a little bit easier to do substitution. So we can rewrite secant as 1 over cosine. And by rewriting it, notice how, again, the cosines conveniently cancel out, so we're left with 1 over 4 theta. And by simplifying it, in this particular example, the trig functions actually go away. So we have no more trig to kind of worry about. If we try substitution, now we'll get, let's see, 1 over 2 pi. Checking out the next one, this time we have 3 trig functions. I really don't feel like plugging in pi, even though pi might be an easier one to evaluate compared to the other ones. Let's see if rewriting it can help us out in any way. So by rewriting tangent as sine over cosine, the cosines conveniently cancel. So we're left with sine over sine, and that's conveniently going to cancel as well. So we're essentially just left with 1, and notice how there's no more theta left, so there is really no way for me to plug in pi. This is our limit value. So actually there's an example where substitution wasn't really needed, we just had to simplify it and we eventually got our answer. So again, substitution is our best bet. Maybe simplifying first might be a good way to go if you do have those multiple trig functions. So taking a look at the bottom, this time we're going to try to take a look at this particular function, and we're going to take a look at if we were to be approaching 0. So if we do try direct substitution first, sine of 0 is 0, over 0, we get that indeterminate form. So according to our chart, or our flow chart, this is when we would try to rewrite this somehow, maybe using a trig identity or factoring, but notice how we can't really do either of those because this is not a sine squared for us to use an identity, and these are just single terms, meaning we cannot factor. So for this particular instance, we do not really have an algebraic way to help us figure out what this limit is. So we're going to go ahead and use our graphing calculator to help us figure out this limit value. We'll go ahead and type in sine of x over x on our calculator, and we'll use the table function to help us go ahead and fill in the values. Again, make sure that your independent is set to ask. That way you hit the table button and you can type in any x value you want. That was pretty simple. So taking a look at your table, Notice how we're going to evaluate these limits from the left of 0, from the right of 0, and therefore we can determine that overall limit. So looking at the theta or x values, 0 would be somewhere in here. So as we approach 0 from the left, looks like we get closer and closer to 1. From the right, it looks like we get closer and closer to 1. So the overall limit looks like it would be 1.